Today's lecture, I'm going to introduce you to your new best friend, the periodic table. So here's our friend, the periodic table. You'll notice that it is very neatly organized. Maybe at this point it's completely indecipherable to you. There's all kinds of strange symbols and numbers all over it. So hopefully by the end of this presentation, you'll be able to feel more comfortable with the periodic table. So let's see. One thing you might notice is that there are nice groups or columns of data on the periodic table. So you can see there's nice straight columns. There's also nice straight rows, and we'll talk about those a little bit later. There are two numbering systems on this periodic table. The columns are numbered 1 through 18 in parentheses. This is the new international system of numbering, but it doesn't give us as much information as we might need later on when we start putting atoms together with one another to create compounds. So the numbering system that I prefer is what I call the old numbering system, and these number using Roman numerals. The first two columns are Roman numeral 1A and 2A. Then this middle portion is primarily B Roman numerals, and we don't deal much with that until maybe you get into a couple years of chemistry, what those Roman numerals in the middle actually represent. And then I've got the last 6 columns on the periodic table are labeled Roman numerals 3A through 8A, or in parentheses in the international system groups 13 through 18. Some of these groups actually have names. So these groups occur because these are elements that have similar chemical properties. Early chemists like Mendeleev noticed that certain elements had similar chemical properties, and as he was compiling his table, he started to put these beneath one another. So one of the groups, group 1A, or in the international system group 1, is called the alkali metals, and these elements, when you put them in water, will produce alkaline solutions. Group 2A, or 2 in the international system, are the alkaline earths. Earth is an old-time word that means oxide, and when I put these metal oxides, things like calcium oxide or magnesium oxide, into water, they also produce alkaline solutions. Group 7A or 17 in the international system are called the halogens. Maybe you have halogen lights in your car. The bulbs contain a small amount of halogen, and I forget which one is in the halogen bulbs, probably chlorine. Nonetheless, these react with metals to form salts, and salt means more than just table salt to chemists. There are many compounds that would technically taste salty, not that you'd want to go around tasting everything in the chemistry lab, but when you react a metal with a halogen such as chlorine or bromine, you're going to end up with a salt. And then we've got group 8A, which are the noble gases, and these elements do not react easily with other elements. In fact, until just recently, the last 20 years, they were assumed to have no reactions at all. But some scientists, don't ever say never, because as soon as you say never, then there's somebody out there that's going to find the most exotic conditions that they can find these to react in. But for the most part, they don't react with anything. Okay, on the periodic table, we have rows of elements as well, and these rows are what we call periods. So the columns are groups, the rows are periods, and roughly these periods correspond to having a similar shell of electrons. So later when we talk about the arrangement of electrons in atoms, we will kind of imagine these arranging themselves in shells of electrons, kind of like an onion. So there's an inner layer and more layers outside of that. In terms of the gross anatomy of the table, there's a section of the periodic table on most periodic tables. Either there's a little blue line that is zigzagging across the table, or several of the boxes will be highlighted. These highlighted boxes are called the metalloids. Previously, they were called semi-metals, and I might, go back and forth and use both terms in class. These are elements that share some of the properties that metals have, for instance, conducting electricity, as well as occasionally having properties that non-metals have, in other words, not conducting electricity. Honestly, in my opinion, these are probably some of the most interesting elements, and they form the basis of our modern electronic life. If it wasn't for these, having the ability to conduct or not conduct, we wouldn't have all the little ones and zeros that go on inside things like our calculators, computers, and cell phones. So these form kind of the basis of what we use in our modern electronics. To the left of the metalloids are the metals. For the most part, the whole left side of the table, except for hydrogen. Hydrogen is placed over there because it has similar arrangement of electrons as with lithium and sodium and the other alkali metals. So actually, technically, hydrogen isn't a member of the alkali metals group, even though I may have made it seem like it was in a previous slide. So nonetheless, all of these elements kind of highlighted in yellow here are metals, and they have all the properties that you would expect for metals. In their pure form, they would be shiny. Most of them will be kind of silver in color, except for copper and gold are about the two elements that are not silverish in color. They conduct electricity very well. They conduct heat very well. You can smash them flat and make coins out of them, so they're malleable. You pull them into long filaments and wires, so they're ductile. So they have all kinds of cool properties. On the other side of the metalloids are the non-metals. And these things, basically everything we just said about metals, you can put not in front of them. They are not good conductors. They're not shiny. You can't whack them and flatten them out and make them into coins easily. So that they're not malleable or ductile. So they've got all of the opposite properties of the metals. In fact, many of these are gases. So for instance, obviously the noble gases are all gases. So helium, neon, argon, krypton, xenon, and radon are all gases. And for that matter, hydrogen, oxygen, fluorine, and chlorine are gases. So there's only relatively few of these that are going to exist as solids. Bromine's a liquid. Okay. Ultimately, this comes down to, the big question: which elements will I need to know for the upcoming test? And I always call these the newspaper and cereal box elements. So these are the type of elements you might read about commonly in the newspaper, or find as trace minerals on a box of cereal. So if I had to say, the first three periods, so the first row, second row, and third row, those are elements that are pretty much everyday elements in the world as well as science. And then there are kind of a hit and miss bunch of elements. Potassium and calcium, you might find those listed on the nutrition labels of cereals. Iron as well. Copper and zinc are common metals out there. Arsenic, I throw it in just because it's been used in the past as a pesticide, and it is so many of its compounds are particularly poisonous. And I have a soft spot in my heart for the halogens and noble gases. So pretty much all of the halogens and noble gases are worth knowing, including bromine and krypton, iodine, and xenon. So let's see, if I get into the fifth period of the table, probably the most interesting things in here are things like silver, tin, and I just mentioned iodine and xenon. If I get down to the sixth period, then things that you might run into, W here is kind of one of those odd elements that the symbol actually doesn't correspond to the name. The name is tungsten, and the W stands for wolfram, and I exactly forget what Mr. Wolfram's connection with tungsten is. I suppose he may have discovered it or had some hand in discovering it. Then, of course, there are platinum and gold, the things that people like to find in their jewelry. And then there is mercury and lead, which would be things that you don't want to find in your jewelry. Radon is a good element to know because Iowa and much of the Midwest is a region where we have high radon concentrations seeping up through our soils, and occasionally this can accumulate in people's houses, and that's not a good thing. So there's a booming business out there in radon mitigation. Radon is a product of the nuclear decay of things like uranium. So uranium is worth knowing, and I always say that uranium is always in the newspaper because the Lady Gaga countries are always messing with that, and I call them the Lady Gaga countries because they're provocative. I don't know if they'll actually ever do anything. So my Lady Gaga countries are Iran and North Korea. I think they just like to mess with the rest of the world's heads. Okay, so once we've kind of oriented ourselves to the periodic table, on an exam situation, I very rarely give you an element and have you give me the symbol. It's just, everybody's got a calculator that they can program, or some of the programmable calculators have periodic tables in them. So I like to have you be able to find the elements according to their location. So if I don't know if I can bring up, come on, with the laser pointer. Okay, so let's see if this shows up in the video here. So if I'm looking for an element in group 4A, so I want to, let's see, group 4A and then period 3. So this is my first period, second period, third period. So in period 3, group 4A, that looks like I'm talking about silicon. So its symbol is Si and its name is silicon. And alkali metal in period 4. So let's see, period 1, 2, 3, 4. So the alkali metal in period 4 would be potassium. Noble gas in period 6. So let's see, noble gas in period 6. Noble gases are over here. Period 6, let's see, 1, 2, 3, 4, 5, 6. That looks like our old friend radon. Metals found in jewelry. So sometimes I'll, kind of, throw you off here. There are all kinds of metals that are typically found in jewelry, probably most commonly platinum and gold. Copper, if some people have copper jewelry because they think it has an impact on their arthritis. Silver is something that's found in jewelry. I was up late one night watching late night shows where they're selling knives and samurai swords. And there was like a section where they were selling jewelry, and they had jewelry that was made out of iridium and osmium. I was crossing my fingers that this was going to be cheap because it would be cool to have an iridium or osmium piece of jewelry, but it's even more expensive than gold and platinum, so it was way beyond my budget. Let's see, gas found in party balloons. Probably the one that's most likely would be helium. It's less dense than air, so it floats. It makes the balloons float in air, rise in air. If you're just filling them with your lungs, you might find some oxygen in there, maybe some nitrogen, actually quite a bit of nitrogen, since most of air is just nitrogen and a smaller quantity of oxygen. So that's kind of how I would present the material on an exam situation.